Okay, so this recording is to talk about what we talked about on Wednesday with slope. So I'm actually going to break up slope into two different videos. The reason why is because I want one of them to be what we talked about Wednesday, what we explored, and then the next one will be basically the video for today, Friday, 11/8, the day that I am not there with you. So let's talk about slope and what you learned from the little lab that you guys did. So we talked about how slope was, there are kind of three ways to think about slope. And actually this is from my old video, but I'll erase this real quick. Three ways to think about slope in terms of a formula. But hopefully you understand it a little bit better than a formula. Slope is defined as rise over run. Another way to think of that is the change in y. So this little triangle means delta, and that stands for change in. You want to get used to using that symbol because you'll see that if you end up taking physics, you may see it in chemistry, it stands for the change in y. And the change in x goes on the bottom. Another way to look at this, which we looked at this formula on Wednesday, is y2 minus y1. Well, that's the change. If I have a second y and a first y, the difference between the two, see how I use the word difference? That difference means subtract over change in x, x2 minus x1. And again, if I have a change in my x value, if I go from x1 to x2, change would be the difference, and difference means subtract. One important thing that a lot of students mix up is, if you notice, well, first let me write down what this x1 and x2 stuff means. So if you have 2 points, one of them you'll label point 1. That's going to be x1 comma y1, and the other one x2 comma y2. So you want to really make sure that, see how x2 and y2 are on top of each other? The points to go together need to stay on top of each other. And y's go on top, x's go on the bottom. So not only are you lining up y's on top, x's on bottom, you also have to line up the 2 points vertically. So hopefully you see that. But I'm a little bit more interested because if you understand on a deeper level what slope is, you'll never make a mistake with this formula. So you guys dealt with the slope of a ramp on Wednesday, and you guys saw that as you made the ramp steeper, as you added books, what happened to your slope number? Hopefully you saw that that slope number went up. The steeper you made it, the actual ratio of y over x increased. So slope is really steepness. So the steeper your line, the bigger the number for slope. Another thing that you guys noticed is, if that's the case, if my number gets smaller, if my slope goes to 0, hopefully you understood that that made a horizontal line. So for example, if I understand that if this is a line, and I make it less steep, so I'm going to kind of alternate colors. If I make it less steep, that's going to have a smaller slope. If I make it even less steep, that's going to have a smaller slope. And I keep doing this. Keep decreasing your slope. So for example, say that this first one had a slope of 5, and then this one has a slope of 4, and this one has a slope of 3. And this is just a sketch, so clearly this might not be true. And actually the way I've drawn it, it's not. But this might be 2, and then this might be 1. Well, hopefully you see as the numbers, as the slopes are decreasing, it's getting closer and closer to being flat until eventually it's going to land here. It's going to be a flat line for 0. Well, if we keep this concept going, imagine what happens if I keep going down. And so this is slightly new from what we talked about, but if I keep rotating around, if I went 5, 4, 3, 2, 1, 0, what's the next number down? Negative. Well, look what happens with that line. Do you see how the line is going down from left to right? So that's a concept you need to understand, that negative slopes go down left to right. So I'll just do one more. So positive slopes go up left to right, in other words, up the mountain, and negative slopes go down left to right. So now let's talk about the actual graph. I mentioned on Wednesday how Noah had a really great question with the skateboard ramp. And what happened was, let me get a line going. Trying to make this just perfect so we can talk about it. Okay, that's pretty close. If we look at this line and we want to find the slope, find two places where it crosses. Well, it crosses here at 0, 0, it crosses here at 1, 2, crosses here, it crosses here. If you want to find rise over run, or your slope, change in y over change in x, y2 minus y1 over x2 minus x1, find any 2 points, make a right triangle. So I can make a right triangle right here. Well, if you notice, I have to go up 2 and right 1. Well, this is the change in y. Remember, y is up and x is right and left. So that means that my slope is going to be 2 over 1. Well, that's equal to 2. Imagine I pick a different pair of points now. So I'm going to make a different triangle. Say I take this bottom point here and go all the way up to this point. So hopefully you see this triangle. Those triangles look similar. They're actually called similar triangles, but they look similar except for one's bigger than the other. So now let's look at this purple one. If you notice, the change in y is 1, 2, 3, 4, 5, 6. And this change in x is 3. I never actually wrote 6, sorry. Change in y is 6, change in x is 3. Well, if I do slope, that's 6 over 3. Well, 6 over 3 reduces to 2. Even though I picked a different triangle, I still have the same slope. And if you notice, 6 over 3 is a ratio, 2 over 1 is a ratio. We learned how to check if two things are equal ratios. In other words, they form a proportion. They're proportional. We just talked about that in the last chapter. So slope is basically a proportional thing. It has the same rate of change for y for rate of change of x. So another way to look at this, there's a thing called a unit rate, which is this 2 over 1. So that means for every increase in x, my graph goes up 2. For every increase in x, my graph goes up 2. For every increase in x, my graph goes up 2. That's what that 2 over 1 means. And so we really need to understand that. So let's talk about now a negative slope, since we haven't done that a lot. And I'm going to do it a little bit differently than I did this so we can get some practice with the other formula and see what it means, really. So the other formula that most people tend to fixate on a little bit too much is the y2 minus y1 over x2 minus x1. So let's look at what that means. I know that you should be able to figure this without a graph, but we'll do it with a graph just to help see what's going on. If I have the point 2, 5, and the point -3, 10, and I want to find out what my slope is between those 2 points. It doesn't matter which one is y2 and y1. I mean, I could label this point 1 and this point 2, or I could label it the other way around. And I want to prove that to you. So first I'll do it this way. Take y2, well that's 10, minus y1, 5, all over x2, negative 3 minus x1, 2. 10 minus 5 is 5. Negative 3 minus 2 is negative 5. So I get a positive 1. I'm going to prove to you now that it doesn't matter which order you choose. Say I labeled this one as 0.1 and this is 0.2. Now if I do y2, 5 minus 10, y1, over x2, 2 minus x1, negative 3, I get negative 5. Remember, 2 minus a negative 3 minus a negative is plus a positive. 2 plus 3 is 5. I did something crazy. Oh, I see what I did. So 5 over negative 5. Hopefully you guys caught me at home while you're watching this and said, Miss Peters, you forgot a negative. 5 divided by negative 5 is negative 1 for this blue one. So now you can see that they're both negative 1, no matter which way you put the order. But now let's actually see this on a graph. So this is to justify that negative goes down. So 2, 5, go right 2, up 5. There's that point. Negative 3, 10. Go to the left 3, up 10, 2, I'm counting the red lines, 2, 4, 6, 8, 10. If I connect those with a ruler, okay, there are my points. So we've seen basically a little bit too far. We've seen this triangle. We've seen the negative 5 over 5 because I go down 1, 2, 3, 4, 5. And I also go right 1, 2, 3, 4, 5. Well, let's talk about what this slope of negative 1 actually means. So that's a little bit more confusing to see. Negative 1. Well, do you see how this graph goes through all of these vertices? Here, 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 here. That negative 1 ratio that we got represents down 1, right 1, 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 forever and ever. Down 1, right 1. So whenever you get for your slope, those are the small versions of the triangle if you reduce it. So your book does a really good job of summarizing when things are positive, when things are negative as far as slope. On page 174, I'm going to talk about a slope of 0 and undefined slope in the next video, as well as slope from a table. So I hope this was helpful for you. Make sure that you can find the slope through a pair of points without a graph. Make sure you can find the slope on a graph, like on number 16 and 17 on page 176. And I'll talk about tables in the next video.